Hello and welcome to Notebook. In your previous year, you must have studied about data, how they're collected and represented. There was also some basic understanding about measures of central tendency. Can you recollect any of these? In this lesson, we will talk about these measures of central tendency in more detail. If you want to have a quick brush up on the topics, you can check out our videos on those lessons, namely data representation and measures of central tendency. Here, we will mainly focus on group data, that is, data grouped into bins or class intervals, represented in the form of frequency distribution tables. First, we will quickly see a few formulas from our previous lessons so that we can take our study further in detail. The mean x bar of a set of data is given as summation fi xi divided by summation fi. I varies from 1 to n, where x is the variable and f is the frequency. Thus, xi is the value of x and fi is the corresponding frequency for the ith observation. N is the total number of observations. For a grouped frequency distribution, xi is the class mark. Class mark can be calculated as lower class limit plus upper class limit divided by 2. Here, if you look at the marks column, the upper and the lower limit numbers are added and divided by 2 to get the values for the second column. This method, where we simply find the class mark and the subsequent mean by finding the weighted average, is called direct method. If you look at the number of plants and the number of houses example, we figure out the class marks first and then calculate the cumulative frequency to get the total in the cumulative column. This method of calculation is called direct method. There are two other methods by which we can find the mean. They are called assumed mean method and step deviation method. Sometimes when the xi's and the fi's are large, that is, the observations and their frequencies are very large, then calculating the products are also very tedious. In that case, we use the method of assumed mean. From the assumed mean method, the actual mean is calculated as x bar is equal to a plus d bar, where d bar is summation fi di divided by summation fi, where I is from 1 to n. N is the total number of observations. Here a is the assumed mean and di is the difference of xi and a for each class interval. Another method, which is very frequently used to tackle a large amount of data, is step deviation method. Here too, as the name suggests, we simplify each class mark into even smaller multiplier of the corresponding frequencies. This is done by calculating the deviation in each step and dividing the result by the class width or class size. In the step deviation method, the mean is calculated as x bar is equal to a plus h multiplied by u bar. Here a is the assumed mean and h is the class width or class size. U is the difference between each class mark and the assumed mean divided by h. Thus, for each class interval, we have a ui. Each ui is multiplied to the corresponding frequency to get fi ui. Thus, u bar is obtained as summation fi ui divided by summation fi. Of course, I is from 1 to n, where n is the total number of observations. Do you know what is hieroglyphs? They are ancient Egyptian writings in the form of pictures and symbols. A statistician's workbook often looks like a page of hieroglyphs, full of symbols, letters, and numbers. Like the ones you see here, it's overwhelming, isn't it? To understand these symbols and formulas, let us see an example. This is the set of data obtained pertaining to the number of plants in the gardens of 100 houses in our locality. The mean of the data by simple averaging is the sum of all the numbers, that is, total number of plants divided by 100. The total number of plants is 6,526. Thus, the mean is 6,526 divided by 100, which is equal to 65.26. Since the data is large, we sort them into different groups and put them into tables. For each class, we also find the class mark Xi. We extend the number of columns in the table to find the product of Xi and Fi, Di, which is the difference between each class mark and an assumed mean, the product of Di and Fi, Ui, which is the factored form of Di, that is, Di divided by the class size, the product of Fi and Ui for each class, and at last we find the total or the summation of all the parameters. For each class, we find the product of Xi and Fi. Since there are two numbers towards the middle of the list of the Xi's, 54.5 and 64.5 respectively, we choose 54.5 as the assumed mean. For each class, we find Di, which is Xi minus the assumed mean 54.5. Next, we find the product of each difference Di and the corresponding frequency Fi. We can see from the table that the size of each class is 10. That is, class width or size is 10. Thus, for each class Ui, which is Di divided by the size 10 is obtained. As before, we multiply this Ui to its corresponding frequency Fi. At the end, all the sums of all these values are obtained. Thus we see that summation Xi Fi is equal to 6,510. Summation Fi is equal to 100. Summation Di Fi is equal to 1060. And summation Ui Fi is 106. Applying the formulas we read above, we see that by direct method, the mean is obtained as X bar equals summation Xi Fi divided by summation Fi, that is 6,510 divided by 100, which is equal to 65.1. By the assumed method, we first find D bar as summation Di divided by summation Fi, that is 1060 divided by 100, which is equal to 10.6. Thus our mean X bar is 10.6 plus the assumed mean 54.5, which is equal to 65.1. With the step deviation method, we see that U bar is summation Ui divided by summation Fi, that is 106 divided by 100, which is equal to 1.06. Thus, X bar is obtained as the product of U bar and class size being added to the assumed mean. Thus, 1.06 multiplied by 10 and the result added to 54.5, which is equal to 65.1. Have you noticed that in all the three cases, the answer comes out to be the same? You may work out each formula and figure out why they obtain the same answer. In fact, each of them are essentially the same process or a simplified form of the direct process. We just try to factor the numbers for ease of calculation. You see, if the Xi's or the observations are small, we may use the direct method. If they are large, any two of the methods are applicable. Also, remember that we can use the step deviation method when not only the observations, that is, Xi's are large, but also the class sizes are different. In that case, we can choose any number h as the suitable divisor for the differences di's. This brings us to the end of this lesson. We are yet to learn about how to find the median and mode of group data. See you super soon in those lessons. Bye.